following Adam's talk because he explained very beautifully about how important functional programming is for when we're using Scala, all the advantages. So I would be continuing to that as well. So I am Shrikha, and our work I'm presenting on behalf of Shiv, Heemmanshuu, and my mentor, Manasa. So when Scala reads like Java, so let's start with something familiar. In large code bases, we have often seen that the Scala code is more of imperative, and it has a lot of loops, mutable variables, nested conditions, and it works, but it's not in the Scala's strength. It can do much more. So we are developing a tool which would help us not lose the functional benefits of our code and provide the refactorings. So if we lose the functional benefits, then the code becomes more stateful and error prone, and it is very lengthy, and there is no structure in the code, and it is not safe for parallelization. When we do some refactorings to make it more functional, we can use parallelization benefit as well. So that's what we are trying to do. We created those patterns and suggesting the functionals refactoring for the same. Let's look at an example. If we suppose have a sequential code which is doing a lot of computation, if we use a .par, then it would parallelly do it, and it would be faster. So these kinds of transformations is what we are providing. In this code, we can see that there is mutation, use of conditions inside for loop, and our tool identifies it and just converts into parallelly using a map, and it is now immutable. So that kind of refactorings is what we propose. So let's look at a demo and see how this actually comes into action. Let me play the video.
Hi, Scala Workshop 2025. I'm Shiv, and I'm going to give you the demo of ScalaF, the functional refactoring tool. So this is the UX of the extension. You can see the refresh button, and once you click it, you get all the refactorings of this file. So here you can scroll between all the refactorings, and you can see that there are total 475 refactorings. Among them, 347 are two refactorings and 171 are conditional refactorings. And if you click on the header of each box, you will go to the selected region in the code, in the text editor. And you can also see there is, when you hover over it, you can see the view details and apply refactorings. And if you have an option to edit your suggested refactoring, and you can either accept or reject it. So here I'm accepting it. There is also an option to, every time you save your code, it automatically fetches the new refactorings for the diff of the file. So you can see this refactoring is considered now. And if you toggle between files, it will also fetch the refactorings of the new file almost instantaneously. Yeah, so there are total 3 refactorings in this page. If you want to clear the UI, you have an option to clear, so it will clean all the UI, and you can also refresh the UI to get the UI back again. There's an option to scan the entire directory to see all the possible refactorings for all the files. Now it is processing all the files of the workspace. Once it's done processing, it will give you the summary of all the refactorings in the workspace. As you can see, in this workspace, there are total 43 files where there are refactorings found, and total refactorings are 627. There's also an option to to add your custom refactorings to the already existing tool. So if I do the new pattern refactor, I have to give a new pattern.txt. Here in this txt, the custom refactoring patterns have to give in a particular format. So you have to give the pattern name and you have to give the original pattern and then the refracted pattern and the description of the pattern. When you give this, from the next time when you try to refresh the page, it will identify even these patterns. That is all from me. Hope you are excited to use this tool. Thank you.
So, let me go to the next slide. There is a QR, you can scan it and use this tool in action. And the source code is available, and the code, basically the backend code, if you don't want to use the tool and just pass in your code base directly, you can do that too. It's easier for large code bases. When we talk about evaluation, so we tried to work through conditionals and loops, and it performs very well in large code bases also, and the backend is working great over there. So we can add more extensible patterns as well and use it in live development. Next, we would want to include it in IntelliJ and add more functionalities to it and test it for more use cases like larger code bases. And that's it.
Thank you very much, and thank you for saving us time, because we're a bit behind in the schedule and quite a bit of time left. Thank you. Okay, cool. Are there any questions? Yep.
Thanks for the talk. Could you talk a little bit more about the language in which you define the patterns? And also, how is it related, if at all, to structural search and replace, which, for example, IntelliJ IDEA has, where you essentially could specify a pattern of some sort of an AST of code, and then it would find those AST nodes and replace them with something else.
Yeah, so basically we go into the AST level and do that, and the backend code is also written in Scala, Meta, and quasi-codes. So we are doing it pure Scala based, and it is not just search and replace. We are going through what it actually is in the AST and identifying how they are structured as well. Like if there is a for loop inside a for loop and things like that, then it gives better refactorings, and that's how it is. Thank you.
Yep.
Thank you for the talk. The demo looks interesting. I have a question, because in the demo you showed that there's a template file that allows you to specify the rules. So is there any kind of verification about the correctness of those or those rules? What if I made a mistake in those rules?
Yeah, so it is basically the human base, like we showed that in the tool we can check if there is an edit option. So it is based on human to verify the correctness of it. And later we might want to do it automatically, but right now it's done manually.
All right, thank you so much for your talk. I hate to have to ask this question, but I'm curious if you've benchmarked this against neural LLM-based approaches.
No, we haven't tried that. It's a good thing. We'll try to do it and get back to you. Thank you for the question.
Okay, thank you very much. Let's thank her again.
Okay, thank you so much.